And I think we can get started. Sarah, would you like to begin?
Absolutely. Thank you, Javier. So welcome to Data for Everyone. My name is Sarah Gonzalez, and I'm a data librarian with Northwestern University's Galter Health Sciences Library and Learning Center. And today I'm co-instructing Data for Everyone with Javier Martinez Rodriguez, a program specialist for the National Center for Data Services of the network of the National Library of Medicine, based at NYU Health Sciences Library. And we're also being joined by Justin De La Cruz, helping out in chat, who is the Associate Director of the National Center for Data Services of the NNLM. And as we move forward, I'll stop video at this point so we can concentrate on slides as we get started. So welcome, everyone. Thank you for attending. The NNLM is the network of the National Library of Medicine, and it is an outreach program of the National Library of Medicine, which is an institute at NIH. The National Library of Medicine is the world's largest biomedical library, which maintains and makes available a vast print collection and produces electronic information resources like Medline Plus and PubMed. NNLM is a program of the NLM and is comprised of 7 regional medical libraries, or RMLs, 4 offices, and 4 centers. Northwestern University is located in Region 6, and the university also hosts the NEC, NNLM's National Center for Evaluation. NCDS, the National Center for Data Services, is hosted at NYU and is in Region 7. So to kick things off for our presentation today, we'd like to ask you all a question, and that is, what do you think of when you hear the word data? Please take a few moments to put your associations with the word data into chat. And thank you. We're getting great responses already. Numbers, statistics, information, qualitative or quantitative measurements. That's great. Absolutely. Content, graphs, charts. Great. Yeah, thank you everyone for contributing. There's really a lot of things that come to mind when we think about data. So that's exactly what we'd like to think about today. It's zillions of bytes of raw research data. That's a good way to think of it too. Great. Thanks everyone for your contributions. So I definitely think we will touch on some of those ideas that were contributed in chat as we go forward with our content today. Okay, so let's move on to our learning objectives for the day. Our goals today are to define common data terms related to health data, to prepare a spreadsheet for creating a simple data visualization, and to identify further learning opportunities for working with data. So first, let's talk about some common data terms. To set the stage for that, for common data terms, first, we'd like to acknowledge that data is really all around us. Every day and in many ways, whether we're aware of it or not, we are generating data and working with data in some way. Perhaps we're looking at the numbers in our health apps, noting how many hours that we slept or steps we walked. Maybe we're looking over the metadata of something we want to watch on a streaming platform, noting the cast list, the description, ratings, etc. Similarly, we could be looking over the descriptors of something we'd like to purchase on a shopping site, noting cost, description, whether the item is available in a variety of colors or sizes, etc. Or maybe we're wrangling a big event in our lives, like a wedding, and keeping track of guest names and addresses, food and flower orders, gift registry items, and more. In each of these scenarios, we are collecting, evaluating, and making decisions for our lives based on data. Now let's move on to some key data definitions. And also, as we're going on, please put questions in chat if you would like. So it can be really helpful to start with basic terminology to differentiate data itself from some of its associated concepts and terms. Scientific data, according to the NIH Data Management and Sharing Policy definition, is the recorded factual material that's commonly accepted in the scientific community as of sufficient quality to validate and replicate research findings, regardless of whether those data are used to support scholarly publications. So that is our really formal definition, but in this class, we will start by focusing on other, more general types of data, such as examples from the previous slide. Data is something people tend to work with in stages. First, it must be collected and recorded. Data input can be defined as a way to capture or record raw data. Examples include health indicators entered into or maybe automatically recorded by a health app, or downloading to our computer a list of last year's Amazon purchases. Then the next stage of working with data is data processing. Processing involves converting that recorded data into a more meaningful form. Examples include tweezing out important information from a downloaded list of purchases or invoices and placing those pieces of information into a spreadsheet. The things that I might like to pick out and analyze could include product names, prices, dates of purchases, and whether the item was a gift item or a personal purchase. So let's take a look at our next slide and visualize that a bit. This is an example of what a spreadsheet containing tweezed out shopping data from invoices might look like. Based on the particular budgeting questions that the shopper would like to answer for themselves, they can construct a spreadsheet with just a few columns, noting things like the product name, how many of each product was purchased, the date of purchase, a unit price, and the total price, and whether the purchase was intended as a gift or as a personal item. By examining these column names and brainstorming a bit, we might already see some potential questions that this data could answer. Questions such as, how much money did the shopper spend on gifts in a given month? These ideas lead us to our next group of definitions. Data analysis is the process of extracting meaningful information from data. It can involve simple sorting and counting, or more complex calculations. Some examples are included on the slide and include things like determining from the shopping data whether more money is spent in one particular month versus another, or determining how often repeat purchases of items happen to see if a good discount could be achieved by using a subscribe and save type of feature. Metadata is information that describes, explains, and otherwise contextualizes the data. The column headers in the shopping data spreadsheet are an example of metadata because they describe what's being recorded, such as the product names or the prices. A variable is any type of symbol that represents information. In addition to being its own type of metadata, the column headers in the shopping data spreadsheet are also variables because they symbolize the shopping data that's recorded in each category. And variables can be found in both quantitative and in qualitative data. A database is an organized collection of data stored electronically. The shopping data spreadsheet is an example of a really simple database, but databases can also be much more complex, storing multiple tables or multiple spreadsheet-like listings of information, and databases can store hundreds, even thousands of variables. So let's move on now to the how-tos of setting up a spreadsheet. Commonly in research studies, data is organized and wrangled in a spreadsheet format. It's helpful to understand basic terminology commonly used in spreadsheet-like settings. So a spreadsheet is set up according to a grid consisting of rectangles, and each individual rectangle is a cell. Each cell contains some type of data, and those contents of the cells are referred to as a value. Common formats for values are numeric, text, and date, just as we may have seen in Excel spreadsheets. Columns are what run up and down the spreadsheet. They are generally formatted to contain the variable as their column header or column name. The variable denotes the name of the data value category that will be collected. Variables should be formatted to contain only one type of value. So therefore, all the values running down each column of a spreadsheet should have the same formats. So running down, they should all be dates or all numeric or all text. And each individual cell should contain only a single value. Rows run from left to right across the spreadsheet. And in spreadsheet settings, rows are generally formatted to contain the instances of observation. So that is the thing or event about which you are recording information. Each instance of observation can consist of recording the values for many different variables. While setting up columns in a spreadsheet, it's best to set up the data type or format that each column is meant to collect as soon as possible. This is done by selecting your column and right-clicking on it and choosing Format Cells from the menu. Most common format types are text, and that is useful for data like product names or personal names, basically anything that must be recorded in words. Numeric is useful for simple numeric counts of things. So this could be prices, patient ages, basically any type of data that is recorded in a number form. Dates is the third most popular type of format. Of course, useful for recording dates themselves, but also sometimes date and time. Well, when you open up the options in your spreadsheet program's date menu, you can see that there are many to choose from. So be sure to look them over very carefully and choose the date format that will work best for your project. On this slide, we're showing a visual example of the data terms that we have just discussed. So each column in the spreadsheet has a column header, which is also its variable name. Columns run down the spreadsheet, while rows, or instances of observation, run across. Unique data values are recorded in each of the individual cells. And then the columns are formatted very specifically to their data, such as the date data being recorded in a month/day/year format, and prices being recorded in the accounting format with 2 decimal places. And the variables that must be recorded in full written words, they are recorded in text format. So at this time, let's take a quick knowledge check. Just within a few minutes, we've already talked about a lot of data concepts and also terms associated with data. So as a check, please type in the chat the letter of your response to the following question. Which of the following are true about data variables? A, variables are symbols that represent some kind of information. B, variable names, number 2 should be B. Variable names are typically recorded as the column headers of spreadsheets. C, our third option, variables can be found in both quantitative and qualitative data. Or D, all of the above. Poll is up now. And thanks everyone for participating. Okay, we're seeing a lot of activity. And also at this time, are there any other questions about the content so far? Do you have one response in chat that's also related to polling? That's good to see. Okay, we're seeing some results. I think activity is just about settled. Okay, let's share the results. I'm not sure if that's visible for everyone. I'm also looking in my system. And just about everyone has voted.
Yes, I believe everybody can see the results. Is that
Okay,
good?
I must be looking at the wrong thing. Okay, so we've got the results, which D, of course, our fourth answer. Variables do apply to each definition that is provided on this slide. So thanks so much, everyone, for voting, and thanks, Javier, for the update. And now, there we go, all of the above. And now I will pass it over to Javier.
Thank you so much, Sarah. Um, uh, okay, again, thank you very much. Um, so what you see here is an example of how we can create data visualizations out of everyday data. And I am going to, one second. It seems like it's not showing the graph properly. So I'm just going to quickly share my screen instead so that you're able to see it. Just one second. Um, and if that is available for everybody, you should be able to see that. Just once. Great. So this is an example of how we can use everyday data. Yes, there's a bike rider there. This is an example of how gathering information about an everyday activity can lead to um, presenting data or analyzing data in different ways. So, oops, my apologies. There we go. Um, Oh, one second. There you go. So yes, this is data from a Reddit user, and this Reddit user recorded it likely using a fitness tracking app as they attempted to bike 1,000 miles in 1 year. So you can see here that the graph on top is a line chart that shows the distance that this person biked, and it accumulates as the year progresses. The bottom left is a bar chart showing their average speed across the year, and then the bottom right is a pie chart showing the type of ride as a percentage. So it seems like this person started riding their bike a lot for their commute, and then they started doing other types of activities that took up some of that percentage. This example illustrates how data is found in everyday activities, but also how one data set can answer many different questions like distance, or like distance that you have biked, your average speed, the type of ride, and what is more or less frequent. So this one data set, which I am assuming included columns for date, distance biked, speed, and ride type, can produce several answers and different graphs depending on what your intention is as a analyst. So as we mentioned before, people work with data in stages. And one of the things we want to do is we want to show you how you can do this and how easily it can be done. As is usual with data, we want to answer a question. That question is going to be, what pets does this group have? So we are going to walk through the process of answering that question using a very simple data set. So the first thing that we need to do is collect our data. We need to collect data to answer a question. We will use another poll for this. Um, we will use another poll for this, and I will launch that in 1 second. So you should be able to see the poll now. Let me know if you can. Just do a thumbs up and please answer. We're really interested also in seeing what kind of pets everybody has in the group. So we're going to do this fairly quickly and do a little bit of data collection here. There's a flaw in the poll. People don't have cats. Cats have people. That's right. Also, sometimes dogs too. I have a dog and I believe he runs this house, not me. Great. So I think we have about some answers there. So I just want to put this out there for you to see some of the results, which you should be able to see now. Yeah, great. So now that we have collected our data and that we have results, let's record that in a spreadsheet. And I am going to do this right here. You should be able to see my screen again. So just 1 second. Let me get rid of some of this. Again, great. And I will share my screen again. Perfect. So now what we need to do is we need to set up our spreadsheet. And I will begin that by naming my columns. So we have two answers. We have the pets, which we are going to just name. We have a column for the type of pets that people have, and we're just going to name that pets. And then we have a number, another column with the number of responses that people gave us. So I'm just going to name that number. Now that I have that, I'm going to enter my values into these columns. So we already have values for the pets, which is essentially the options that were provided. So those options were cats, dogs and cats, other, and none. And I understand that there's also a lot of variety there, but we limited the poll to one answer only. But it's really interesting to see the pets that people have. So now that I have that, I just need to record the numbers based on the results that I have on my poll. So it seems like out of the people who responded, we had 16 people saying that they had dogs, 20 people said they had cats, 9 people said they have both, 1 person said other, and then 32 people reported having no pets. So now that I have this information, I want to make sure that my spreadsheet is going to work smoothly. So a part of that is making sure that all of the values in my spreadsheet are set up to the right format. So I'm going to select all of my numbers, and here in Google Sheets, which is what we're using, I will go to Format and go to Number and select Number. It automatically adds to decimal points. It doesn't affect my information right now, so I'm going to leave it, but you just know that you can, um, in Google Sheets, you can change the number of decimal points using these two options right here. And in fact, let's just go ahead and move that decimal point, go back to integers. Finally, so now you have a data set, you have a spreadsheet, and what I want to show is how you can present this information in a more compelling way by creating a graph or a chart. So in order to do that, I'm going to select my information. So I'm going to select my data set, and I am going to choose Insert Chart. And just like that, you can see that Google Sheets has generated a bar chart with all the information that we have in our spreadsheet. And you can see here that this is perhaps a more compelling way. Um, perhaps in a more compelling way, you can see that most of the people do not report not having any pets, but after that, you can see the order is cats, dogs and cats, and then other. And that is perhaps an easier way to do that. Perfect. So now that we have that going on, we want to give you the opportunity to do it yourself. So in order to do that, we are going to run a third poll, and it's about whether everybody in this group prefers chocolate or vanilla flavor. So I'm going to open that poll now. Sorry, one second. And you should be able to select an option. I know. I see that somebody said that it's actually dulce de leche, which is one of my favorites too, but we wanted to uh, keep the data points uh, at a slower, we wanted to keep a smaller number of um, variables. Just for practice, but it's also a really interesting question. And if you would like to include no answer in your spreadsheet, in your data set, that's also an option for you. There was a question in the chat about that. Okay, so I think we are going to finish this poll, and we're going to share the results with you. Just 1 second. Okay, great. So everybody should be able to see the results here, and so you should be able to create a spreadsheet using a software of your choice. Some people prefer Excel. I did the demonstration using Google Sheets. You can use Google Sheets. It's easy to use. And then create a visualization using the following steps. Give us a thumbs up and let us know what you found, what you thought about the process in the chat. Cool. So I see already a thumbs up there. I see that somebody is not able to see the results. Um, I am going to then put them in the chat. Just 1 second. Okay. So I see we also got a lot of thumbs up. So I'm going to continue, but please let us know if you encounter any challenges setting up that information in the chat. So also, we want to know if you have any questions. If you have any questions about spreadsheets or about working or about some general terms with data, this is an opportunity. So I'll give a couple minutes for questions and you can let us know. So I see a question here. We can see 31 individuals did not respond. Can this be added even though an answer was not provided? That is a really good question having to do with whether or not a piece of information is relevant to the question that you're trying to answer. So you may find that you can you can say essentially what the number of non-responses are if you feel like that is part of the narrative you want to include with your data. Because essentially we use data to answer questions in different ways, and data essentially tells a story. So if it's an important part of your story that a lot of people did not respond, then definitely include that. But for the most part, people tend to just not include that in their data sets and simply mention it in other parts of their reports. What is easier to use, Excel or Google Sheets? Bit of a matter of preference. I find Google Sheets is easier to use, but a lot of people really like Excel, and um, a lot of researchers also just tend to use Excel. But I find that the Google Sheets interface is a little bit friendlier. If you are um, a person who is also trying to share your data set with a lot of people and maybe work on it synchronously with a group, Google Sheets makes that a little bit easier than Excel, in my opinion. But it's really a matter of preference. This is not sponsored at all by Google. Um, Okay, sometimes I'll see something like a data dictionary or explainer accompany spreadsheet data. And I was wondering if creating a document like that is necessary for most data sets or other times when it wouldn't be needed. Yes, it is definitely recommended for you to write documentation on when it comes to accompany your data, basically. And that includes explanations of maybe how the data was collected, what the metadata means. So if you have terms in your essentially the names of your columns, right? The names of your variables. You want to make sure that you are letting other people know what exactly you mean. So when we say pets, what do we mean by pet? Which may seem obvious, but then you want to make sure that people have a clear idea of what you're saying. So documentation about explains what's going on with your data is always good to have. Are you required to have an account to use Google Sheets? I do believe you are required to have a Google profile. Sometimes you can set up a Google profile without Gmail. Um, so you can always try that. Do you think most jobs require some sort of knowledge in data sorting? What if it isn't your strongest suit? I don't want to say that most jobs require some knowledge in data sorting or working with data. I do think that more jobs are requiring some form of knowledge of data work. So it's definitely good being at least somewhat familiar with these terms, which is the purpose of this class, knowing how, if somebody's talking to you about data, it's probably good to know what they're saying. But at the end of the day, I'm sure that regardless of your skill set, there are other skills and other parts of your professional experience that will bring value to whatever position you have. Um, do we use a data point for no answer? Again, your choice. It's probably good practice, probably good for you to practice, but uh, your choice depending on how you want to answer the question that you have. Um, Can you share more about how to code data from our spreadsheet work? So if you're interested in coding, we do have other resources for that, and we'll get into that in a minute. Can I show one more time how I created the chart? Yes, I will show you again. I'm going to share my screen right here. So you can see that I have my data set. I will select the part of my data set that I want to show, which in this case is everything. And I will click on Insert and then Chart. And there you have a chart within my spreadsheet. Is there sound? Can people not hear me?
I know, we're hearing you.
Okay, great. Can you have the spreadsheet pull the data automatically from polling instead of typing it in? Um, Instead, if you have a poll with 10 questions, that could be a lot of data to manually type in. Yes, that is something that can be done, especially with certain data collection tools. Will allow you to export the answers to your surveys or questionnaires essentially directly from that platform. So if a researcher is using something like RedCap or Qualtrics, even Google Forms will let you just export the data in the form of a spreadsheet, and then you can work from there. Is that why sample size is important? Sample size is a statistic term, and we do have a class on statistics. I'm not a statistician, but I can tell you that sample size, in my understanding, as a non-statistician, is important depending on how much you want your results to be. Um, I'm struggling to find their word in English, but how much do you want to extrapolate your results to other populations, basically? Um, Code the data for a meaning. Okay. I should have said code the data for meaning. I'm not sure what you mean by that. Some agencies block Google Docs. That's true. So you can use Excel, and it's the same pathway for a chart. It's just insert chart. Um, If you use other, which might allow for specific answers, like with the first poll, there might be an option to provide, yes, you can have specify with an option with other, especially if you create a data collection tool. We did not do that because we didn't want to create a massive spreadsheet that I would have to demonstrate live. But yes, that's always, it can be good practice if you really need to, if you really want to do that. Okay, I see Justin has answered some questions. It seems like people can hear me. Great. Great. So let's move on. Those are all the questions I saw in the chat. Thank you everybody for your questions. So now we just want to share some further learning opportunities, ideas of where you can go to get started working with data or learning about how to work with data, and also suggestions of NNLM classes. So we list all those classes, the URLs to their class catalog pages are in the slides, which we will send to you. And from those links, you will be able to sign up for a class or find the latest recording of a previous class. There are a number of classes from the NNLM on data, from data services and data science to data management plans and open science. We created a guide on the NNLM website, which is called the NNLM Data Pathways. It helps you navigate those offerings. There are paths through generalist for those looking for a broad understanding of data librarianship, as well as data management and data science for those looking to specialize in those areas. We've broken down the classes in the next couple slides along experience level. These are the most introductory classes you can take. We have on-demand classes, which are available now or anytime. They are asynchronous, and we have uh, the recently revised data services on demand classes. They're each, and they include, research data management, research data sharing, supporting open science, and data ethics. There are also on-demand classes on health data standards and the common data elements, which are a list or repository of standardized data collection items. There are also recorded webinars, which you can view on demand on the NNLM YouTube channel, or you can also find it in the class page in the NNLM website. A few that we've highlighted here is making sense of numbers, communicating numerical health information, health statistics on the web, the research data services landscape, how do you start and where does your library fit in, and also greatest crimes in statistics. So here are examples of some of more specific or more in-depth classes to help advance your skills or working with specific tools. So under data management, there's creating data management plans with DMP tool and fundamentals of health data sciences, research data management. That is a multi-week scheduled class that we do asynchronously, and there's open registration for those once a year, which and that you would have to check in on the website to see if registration is open. Under data science, um, there is a new class on open tools for data de-identification, which focuses on the NLM Scrubber, which is a tool to remove protected health information from electronic health records that also discusses the basics of AI. There's also a Fundamental of Health Data Sciences course, which we do synchronously as well. The data management and sharing policy is a popular topic, especially with the policy having gone into effect in January of 2023. We do have webinar recordings that give an overview of the NIH DMS policy. There is also the NNLM immersion workshop that we hosted in the winter of 2023, and that is available on demand. And so these are all recordings and activities centered around the NIH Data Management and Sharing Plans 6-element framework. The Practitioner's Perspective series is comprised of recordings of the NIH DMS policy from experts in preparation for the NIH DMS policy. And finally, Region 3 of NNLM hosted a webinar on the NIH data management and sharing policy for non-data librarians, and you can find a recording for that on the NNLM YouTube channel. For diving deeper or stepping out of the NNLM realm, there are non-NNLM options. A good place to start is the Carpentries, which is an international reaching nonprofit community-led it's a nonprofit community-led organization that teaches foundational coding and data science skills. The library carpentry focuses on building software and data skills within library and information-related communities. All of their lessons and their materials are freely available, and they are open, and you can follow along their lessons and examples. And then the Data Services Continuing Professional Education is a 10-week online intensive learning experience geared toward preparing early to mid-career librarians to provide needed data services. This program runs in the fall and consists of live sessions, remote self-paced learning, and a capstone. And applications tend to open in the summer, so you may have to wait until next year. For further resources, the Data Literacy Project has some free courses on data foundations and data-informed decision-making, but is more business-focused. Georgia State University Library Research Data Services created micro-credential badges for becoming data ready, and there are recordings of all their workshops. Their program includes bite-sized intros to data literacy and full workshops on programs like R, Python, SAS, and Tableau. And the last article discusses becoming data literate and how learning about data can enhance your communication, critical thinking, and research skills. This slide contains links to glossaries and other resources for commonly used data terminology in the health sciences. We derived many of the definitions for this class from these resources, which will be available to you in the slides. Finally, this slide contains some of our upcoming NNLM classes that are related to working with data. Some of them are happening really soon. Pathways to Data Services, session 4 is part of the NCDS short course, which is finishing up. We're wrapping up tomorrow, but the recording should be available in the NNLM class website. We also have session on creating data management plans with DMP tool on November 6th, and we are having the research data services landscape on November 18th. And these are all links to the registration pages for all that. Are there any questions at this point?
Could I hop in to say that someone asked about certification? We do work with the Medical Library Association on their data services specialization. Some of our classes apply to that, but they also have additional classes themselves. And I placed a link in the chat. Check it out. We have a guide to that specialization, and NNLM also helps with funding for that.
Yes, NNLM also offers sponsorship for the data services, for any specialization really, but also the data services specialization through for MLA. So you should be able to apply for that, and all of that information is linked on that website. Can I repeat the courses in Georgia? I believe that is here. There's a link to those recordings there for the data ready badges, and you should be able to find these in the slides, which we will send to you after this class is over. The links in this presentation will be shared. Yes, the links are in the slides, and the slides will be sent to you. They will be shared with you. And you're welcome, everybody who is saying thank you.
Thanks for watching. This video was produced by the network of the National Library of Medicine. Select the circular channel icon to subscribe to our channel or select a video thumbnail to watch another video from the channel.